Hi, everyone. Thank you so much for coming. My name is Kristen O'Leary, and I'm going to be talking today about the Java evolution of Eclipse Collections. So, brief agenda for what we're going to go through today, a quick introduction about myself. What is Eclipse Collections, for those of you who don't know? And then we're going to go through a bunch of new features that were included in the 8.0 release. This release coordinating with the Java 8 release. So we included a lot of new changes that correspond with new Java 8 features as well. So we'll talk about optional collectors, default methods, and then we'll take a look at our primitive collections and how they can work with Java 8. And then we'll take a look forward into what's going on with the pending Java 9 release. And then if we have some time, I have some other stuff we can look at too. So a little bit about myself. I'm a software developer at Goldman Sachs. I am a contributor to GS/Eclipse Collections for the last 5 years. So Eclipse Collections was formerly known as GS Collections. Prior to that, it was developed internally for about 12 years. And I have been an Eclipse Collections Kata instructor and contributor. So the Kata is our set of tutorials. So if you don't know what Eclipse Collections is and after this talk you want to check it out or learn more about it, I highly recommend you take a look there. So I can point you to that at the end. And I'm an Eclipse Collections advocate, so I've been at a lot of cool conferences talking at the Goldman Sachs booth, the Eclipse booth, about Eclipse Collections, spreading the word about it, and just teaching people about it. So what is Eclipse Collections? So just before I get into the slide, show of hands, who has heard of Eclipse Collections before and knows what it is? Okay, great. And then out of that group, who uses it in their projects? Awesome. Okay, so for those of you who haven't raised your hand, hopefully this talk will encourage you to take a look and try it out in your Java projects. So Eclipse Collections is a feature-rich, memory-efficient Java collections framework. It was open source in 2012 as GS Collections, as I mentioned. And now with our 8.0 release, we are now compatible with Java 8 and above. So prior to the 8.0 release, we were compatible with versions 5 through 7. Starting with 8.0, we're saying you're only compatible with Java 8 because we wanted to leverage a lot of the new things that Java 8 brought about. So we'll look at a lot of those in a minute. Our Eclipse page is eclipse.org/collections, another good resource. There's all types of links there, links to our GitHub account, links to the Kata, memory, performance charts, other talks, things like that. A good splash page for you to learn about it. And also, most importantly, Eclipse Collections is open for contributions. So if you do use Eclipse Collections and you want to contribute back to it, you think there's something missing that you could use, we're more than happy to take your contributions. So you can click on the link below to learn how to get started with that. So new features in 8.0. So version 8 for Java 8. As I mentioned before, Eclipse Collections worked with Java 8. You could use things like lambdas and method references, no problem. They actually worked really well with our existing API. But that's pretty much all you got. You couldn't use any of the new Java 8 specific features that were not available before. So we didn't require it or embrace it, really. So version 8 changed that. So now, if you have Java 8 code, it's a very, very easy transition to Eclipse Collections. And if you have Eclipse Collections code, it's way easier for you to use Java 8's features like collections and streams. So we'll take a look at a lot of examples coming up for that. So one of the first things that's new with Eclipse 8 is that our functional interfaces now extend the Java 8 functional interfaces. So this gives us some new interop with Java 8 features directly in our own API. So I'm going to cover all of these methods coming up next. Reduce in place, detect optional. If you're familiar with the collectors class in Java, we have taken it a step further and made our own collectors class called collectors2. Again, we'll cover that shortly. We've made use of default methods. So we've been able to write a lot of new features on our interfaces, and we've gotten a lot more features with less code. And primitive collections in Java 8, we'll talk about some of the specialized things you can do there and how it compares with the Java 8 primitives. So the first thing I'm going to talk about is optional. So again, show of hands, who uses optional? Awesome, me too. I love optional. I think it's a great feature. Before I get into optional specifically, I'm going to just quickly walk you through our domain. So I have a lot of code examples coming up. And the domain that these code examples come from is we have a list of people. Each person object has a first name, a last name, and a list of pets. Each pet has a pet type, a name, and an age. And pet type can either be cat, dog, hamster, turtle, bird, or snake, just an enum to specify what type of pet it is. So we're going to walk through some examples made up that involve this person pet domain. So back to optional. It is a new JDK feature for those of you who don't know, and directly from the Java doc, it's a container object which may or may not contain a non-null value. If a value is present will return true, and get will return the value. So basically, it's a way for you to avoid null pointer exceptions. It's a way for you to wrap your objects around, and so you can check beforehand if they're null or not. So it saves you a lot of those nasty errors. So we think this is great. Now, where can we use this in Eclipse collections? So rich iterables detect with is one example. Rich iterable is one of our highest sitting interfaces, and we have a lot of API on it that our collections inherit from. So detect with is essentially, you can read the Java doc, but it's essentially a way to iterate through a list, and you're saying, find me the first object in this list that satisfies a certain predicate. So it will return to you the object if it finds one, but if it doesn't, it will return null. So this is kind of a great case for us where we can start incorporating optional into our framework so that you don't have to deal with getting back null values. So what happens? So from the kata, this is taken from our set of tutorials, we want to find Mary Smith. So in this example, this .people is our list of people, and we're saying detect with. The first parameter is our method reference to this method on person called named, and the second parameter is Mary Smith. So we're basically saying find me a person in my list called Mary Smith. If she's there, she will get set to the person object. But in this case, Mary Smith is not in our list, so we're getting back a null value. So what happens when I throw my assertions? I get a null pointer exception because Mary Smith returned back null. So pre-Java 8, there's a couple ways we can solve this, or excuse me, Eclipse Collections 8.0, there's a couple ways we can solve this. We could write a simple null check, say if person is null, create a new object, and then my assertions, the test will pass. This probably looks familiar to a lot of you. I know I've definitely written code like this before, but it's not the prettiest, it's not the greatest. Another option before the 8.0 release was we could call detect with if none. So we could find Mary Smith or create her. So again, this was prior to the 8.0 release. We have this other method, which is basically saying find me Mary Smith. If there's not one there, create a new one. That solves our problem. That's great. The test passes. But now with 8.0, we want to use things like optional. They're really handy, and why not? So we want to find Mary Smith or create her, but instead, we are calling the method detect with optional. So now we don't have to pass that third parameter in, and instead of getting a person object back, we're now getting an optional wrapper with the type person. So she's either there or she isn't. So now we're saying optional or else get. So we're saying if the optional is null, get us a new person, which is then created, and again, the test passes. So again, a nice way for us to handle nulls and use it with a Java 8 style. I think it's really, really useful. So collectors. What is a collector? Who uses collectors in their code today? Yeah, if you use streams, I'm sure you use them a lot. That's awesome. Okay, so again, new feature in Java 8. It is a way to implement a mutable reduction operation. So basically something we can do is accumulate into a collection. So again, if you're familiar with streams, I'm sure you've used this before. And the JDK has several built-in collectors. So let's take a look at some examples. So in this, these are all just plain Java examples, no Eclipse collections yet. So in the first example, we have our list of people. We're calling stream on it, and we're mapping each person to their first name, and then we're saying put that into a list for me, which is collectors.toList. And so what that does is it takes our stream and it puts everything into a list of first names, and the output is Bob, Ted, and Jake. Similarly, something else cool that we can do is instead of doing any type of map or anything, we just want to get a sum or a total of something. In this example, we're calling stream on people, and we're saying collectors.summing int person get number of pets. So it's taking each person's number of pets, summing them, and returning back a total to us. So these are really cool, and we wanted a way for our users to use collectors as well with an extended API based on all of the features that we have in Eclipse Collections. So starting with 8.0, we can leverage collectors. Awesome. So we now have some built in as well, collectors too. There's really no interesting naming convention here. It's just if you're typing collectors in your IDE, hopefully the autocomplete, you'll see collectors too, and you'll be inspired to use it. So basically just copy the JDK name. But we have a lot more built in as well. So let's take a look at those. So in this example, we are collecting into a bag. So we have a list of people. We're mapping each person to their pets. We're flat mapping and streaming those again. And then we're collecting into a bag. A bag is an Eclipse collection specific type. Essentially behind the scenes, it's a map of item to count. So when you get this back, conceptually the bag looks like dog, 2, cat, 1, snake, 1, meaning there's 2 dogs, 1 cat, and 1 snake. So since this is an Eclipse collection specific type, this is a great way for us to leverage collectors too if you wanted to put something into an Eclipse collections type that doesn't exist in the JDK. So in the next example, we have our list of people, we're streaming again, we're filtering the people who have cats, and now we are collecting them into an immutable set. So Eclipse Collections has a full immutability complement and library. So if you want to use any type of immutable data structure, you can use collectors too to put them in now if you're streaming originally. So now we end up with an immutable set of person and the contents is Bob. Okay, so this is going to be a diagram that shows you, scratches the surface really of a lot of the main types of collectors to APIs that you can use. So we have most types. So you saw things like toImmutableSet. We have things like toImmutableList, toSet, toSortedSet, blah, blah, blah. All things that currently are not exactly on the JDK, but we have like bimaps, bags, etc. You can do things like collect, select, reject, things that are similar in the JDK, but if you want to use those types, you certainly can. We have primitive collections, which again, I'm going to cover in detail further, but we have a full primitive collections library as well. So if you want to collect into a primitive collection, you can do that using one of these. And again, these are just some examples. There's way more. We have a full set of multi-maps, which is, again, an Eclipse Collections concept, not really in the JDK unless you wanted to implement it yourself. So you can do things like group by, say, toList multi-map or toImmutable bag multi-map. So you can see we have all these varieties of different types of multi-maps that you can use. So any type you want, it's probably there. Miscellaneous, we have some extra API that I think is really cool. So for example, chunk basically puts things into batches for you. So you can say chunk my collection into 2s and it will create batches of size 2. Partition, make string we'll look at in the next example. And then zip and zip with index will return back to you a list of pairs. So again, all API that exists on our list, sets, maps, etc. directly, but if you're using collectors, now you can use these as well to get into those collections. Okay, so here's some nice ways we can see some interop with collectors and collectors too. These 2 examples produce the same exact output, but let's take a look at how they're different. So in this, actually I'm going to look at the second example first. We have our list of people, we're streaming them, we're grouping them by their number of pets, and then we're saying map each pet to a string, and each number of pets to a string, and then join them by commas. So what we're basically doing is we're getting an output of how many pets each person has. Whereas in the first example, we're using collectors grouping by again, which is the JDK8 one, but we're using collectors to.makeString. So as you can see, we achieved the same result here, but it saved us a little bit of code, and I think it's a bit more intuitive. So this is a nice way, they're not mutually exclusive, so you can definitely use them together and to your benefit, so it will save you some time and maybe some lines of code. Are there any questions before I move on? I know I'm saying a lot of material fast. Yeah? Sure, a multi-map is basically a map where there's a key to a list or a set or something else of values. Okay. Okay. Default methods. So who uses default methods? I'm just going to go through all the lists. Okay. For a framework like Eclipse Collections, which is very large, default methods really come in handy. So we'll walk through one example. So as I mentioned, rich iterable is one of our highest level interfaces. So if we want to add new functionality and we don't use a default method, we have a lot of cascading things we have to implement on the way down. So default methods are a great way for us to add new features without having to write all of the code that we would have to otherwise. I mean, this is probably overwritten in a few places, but for the most part, makes our lives a lot easier. So reduce in place is a method that produces the equivalent result as a collector. So all the things we've seen, collect, passing in a collector, this will do the same result. So why do we need this? So in this example, we'll show simply we have a list of people. We're streaming them. We're filtering them based on their pet type, see who has dogs, and then we are collecting them into an immutable set. Whereas in the second example, we are using reduce in place instead. So we're not calling stream. We're just saying select people who have dogs and reduce in place. So this is the API we could use if we are not in the stream sense, but we still want to use collectors. So in the second example, I didn't call stream at all, but I can still pass in a collector and get the same result. So the contents of the set is Bob and Ted. They're the people who have dogs. Where this really comes in handy, though, is if we use our immutable or lazy API. So currently, as it stands today, if you were to use the Eclipse Collections immutable library, you can't call stream on it. Same thing with our lazy iterables, you can't call stream on them. Subject to change in the future, but for now, this will not compile as is. So if we want to use collectors, reduce in place is our way to do that without having to conflict with the stream API and still keeping the types that we want. So in this example, we're calling as lazy. By the way, as lazy and stream are pretty much the same thing because streams evaluate lazily. So at this point, stream is no longer available. We're selecting people who have dogs, and we're saying reduce in place collectors.toSet, and notice that I'm just using a JDK collector in this case. I'm not using Eclipse Collections, and I just end up with a plain old hash set. So again, a nice way for us to use collectors in a situation where we wouldn't have been able to otherwise. Okay, primitive collections. So we've had primitive collections since GS Collections 3.0, so we've had them for a really long time. They are memory optimized collections for primitive types. We have a similar interface hierarchy to the object collections. We try to keep the APIs as similar as possible. There are some gaps, so if you use them and you find something missing, feel free to contribute it back. And we have symmetry among the primitive types, meaning it doesn't matter if you're using an int, long, float, double, etc. We have the same API because we code generate all of our primitive classes. We don't handwrite all of them. That would take forever. So we have symmetry across the primitive types, which is really nice. So how much should an int cost? This is one of our memory comparison charts, and it shows you the benefits of using primitive collections if you can versus an object collection. So the orange is the JDK array list of type integer, and then the blue and green, respectively, are GS collections and Trove, and their memory performances with an int list, or an int array list, excuse me. So again, as your element size really increases, it really does save you a lot of memory. So something to consider if you're dealing with things that could potentially be primitive. So a list of integer versus an int list. Java has object and primitive arrays, but as you all probably know, primitive arrays really have no behaviors besides length. Java does not have primitive lists, sets, or maps, so primitives must be boxed, and boxing is expensive. We have reference and a header and alignment. So this is just a quick comparison chart between the primitive versus JDK collections that you can get with Eclipse collections versus the plain old Java collections. So as I mentioned, we have primitive lists, sets, maps, and stacks and bags, and versus you'd have to box all of these in the JDK, and for things like bags, you'd have to create a map first and then box them. Since bag isn't readily available for you, you'd have to implement it yourself. Where this becomes interesting is with the stream API, we do get primitives, but only for int, long, and double. So if you want to use the lazy API in Eclipse collections, you will get all 8 primitives. So as I mentioned, Java only has 3 primitive streams, int, long, and double. To get into the primitive collection side of things, you would call int stream.of versus stream.of for creation. They have specialized lambda expressions, and they are interchangeable between the primitive and the object types. Excuse me, streams. Lazy iterable is essentially our version of stream API, and we have it for all 8 primitive types. You would call as lazy on your collection for creation, and the API is similar to the object and type specific. And again, we have specialized functional interfaces as well. these can now be used in Java 8 streams too, which we'll take a look at. And as we'll show in the next example, they are reusable, which is pretty cool. So use or reuse. So streams are like iterators. Once you use them, you can't use them again. So in this example, we're creating an int stream of 1, 2, and 3. And we're calling min get as int. We get 1. Great. And then when we try and call max on the stream, we get an illegal state exception with it saying the stream has already been operated upon or closed. So unfortunately, we can't reuse this stream once we've already used it once. Whereas if you have a lazy iterable, you can use it as many times as you want. So in this case, we're creating a new int array list of 1, 2, and 3. We're calling as lazy on it, which is essentially the same type of API. And we're calling min, we get 1. We call max, we get 3. No problem, we're done. So again, an interesting thing to consider if you plan on reusing these types of things. If you want lazy evaluation, this is a great way to do it. So now I'm going to walk you through some code examples using primitive collections and what you'd have to do in both streams or the lazy APIs. So we want to filter pet ages appearing only once. So in the first example, we have our list of people. We're streaming them. We're flat mapping each person to their pets. And then what I find interesting here is we have to call stream again, because once we flat map on the pets, we're out of the stream. We have to create a new one. And then we are collecting them with our favorite collectors. We are grouping each pet by their age, and we're counting how many there are of that age. Entry set stream. Then we're saying filter each get value equals 1. And then we are collecting them into a list. So what this is doing is we're saying get all the pet ages, filter the ones that equal 1, and return it to me. So we end up with a list of a map of entry integered along, and the output is 3 appearing once and 4 appearing once. Whereas if you want to use this using primitive collections and lazy API with Eclipse collections, you have your list of people, you call as lazy, you flat collect the pets, collect int, which when we say collect int, that's our signal that now we're going into the primitive side of things. We want to get the int value, not the integer value when we call pet.getAge, and 2 bags. So at this point, we have an int bag. We don't have to worry about, oh, we went back to the object side. As soon as you enter the collect int stage of things, it knows you're using a primitive collection and you don't have to worry about it going back to the object side. We call toBag. We call select by occurrences, which is our way of saying, tell me the occurrences that are equal to 1. So we get the same output, 3 and 4, and we end up with a primitive collection instead. Find the mode of pet age. So find the most occurring pet age. So essentially this is what we call in Eclipse Collections top occurrences. So in the first example, we have our list of people, we're streaming them, we're flat, this is all the same as before, we're getting the pet ages and counting them. Now what we want to do is we want to sort the occurrences, comparing by value. And then what's interesting here is we have to call reverse, so we get the most frequent pet age on top. And then we're saying limit 1, get me the first one, and then collecting it into a list, and the output is 2 occurring twice. Whereas in Eclipse Collections, if you use a bag, you already have the API called top occurrences, so we're calling as lazy, we're flat collecting the pets. We're collecting ints of their ages, we're calling toBag on them, and we're saying, give me the number 1 top occurrence. So again, we're getting age 2 occurring twice. So this example is very similar. Find least frequent pet age. You'll see the only differences here between the last example and this one is we don't have to call reverse here because now we want the bottom occurrences. Sorry, do you have a question? Bags are not sorted, no. It's basically a map behind the scenes. So in this example, we're just getting the bottom ones. We don't have to reverse them, but same idea, 3 occurred once. Whereas when we called top occurrences here, the only difference is now we're calling bottom occurrences. So we occur at once. Alrighty, so Java 9. So who's excited for Java 9? Yeah? Yeah, got lots of enthusiasm back there, that's awesome. So Java 9, as I'm sure we know, will introduce many interesting changes to the Java ecosystem. So just to name a few, we're going to have the module system and internal API encapsulation. So Eclipse Collections must, in bold, must change in order to be compatible. As it stands, well, as it stood prior to the 8.2 release, we need to include some fixes to get ready for Java 9 ourselves. So one of the examples that we ran into trouble with is methods using reflection. So we need to change our methods that use reflection in order to build. So I'm going to show you a quick demo as to one of the things that we had as a problem, and I'll show you what we did to fix it. Okay. This one first. So full disclosure, this is the Eclipse Collections kata. I have repurposed it for my demo. But the most important thing, actually, let me make this bigger. Okay, much better. So we are using version 8.1.0. This was our 8.2 was released on Friday. So with this one, we have not yet included any Java 9 types of fixes. So demo. Okay. So in this demo, am using one of our static utility classes called ArrayListIterate. So I have an array list of people. You know, we would typically never do this with Eclipse Collections because you don't need to make array lists. We have our own versions of lists. But for the purposes of this demo, let's say I'm using some legacy code and I just want some API on an array list. So I have my list of people, and I am calling ArrayListIterate.AllSatisfy. So this is going to return true or false based on some kind of predicate. My first parameter is my list of people, and I'm saying for all my people, check to see if each person has a pet of type cat. And then I'm going to assert false that all people don't have cats. So what happens when I run this? So as you can see, we're running with Java 9, and I get an exception in initializer error caused by Java lang reflect blah, 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 blah. As you can see, what this is basically saying is you were using reflection on ArrayList, and you can't do that anymore. So how do we fix this so that our users don't run into this problem if they're using Java 9? Let me get out of... Switching IDs. Okay, now I have number 2. So let me... So in this version, I am using 8.2, which was just released on Friday with some of our fancy Java 9 fixes. So I'm going to run the test again. And it passes. Great. So what did we do? So our problem lied within this setAccessible method, calling true on it. We can't do this anymore with Java 9. We can't use this reflection, sadly, unfortunately. So what we had to do was add this new data equals null and size equals null so that these fields were initialized and not just thrown away. This catch block was originally empty. So this is how we fixed it in order just to pass it through. Unfortunately, this means that when we iterate through our array lists, this was done for optimization purposes. We don't know exactly what the implications of that are to see speed ups, slowdowns. I have promised I would write a JMH test to see how the differences are, but TBD. So unfortunately, can't do that anymore, can't optimize our iterations, but we're still able to work with Java 9. So again, that's just a very small example of one of the things we had to do. So workarounds for reflection. This is an interesting, if you're curious, mail with the OpenJDK. I can open it if we want, but basically what this is saying is if you're using reflection and you want to use Java 9, but you're not quite ready to get rid of all your reflection calls, you can avoid this with the command line arguments. I forget what it is, but it's basically a way of flagging saying ignore all the reflection types of errors. But because we're a framework, we proactively solve the problem because we wouldn't want our users to have to do that on account of us. We want to at least make sure we're compatible, we're ready, we won't cause you any troubles when Java 9 gets released. So with that, I think we have some extra time. So here are some links to the 8.2 release, which again was released on Friday, has a lot more of these Java 9 types of fixes if you're curious and looking. The second link is a link to a presentation given by Donald Robb and Maurice Naftalin at Java 1 back in September, and it's all about collectors. So if you thought the collectors piece was interesting to you, it's definitely a good piece to check out to learn even more about it and specifically how to create your own. And then since we have some time, and I always get questions about this, we have a presentation linking to some of our memory benchmarks and performance tests. So I'm going to open those up and just give you a quick look at what we have. So how do I make this bigger? Can I make this bigger? Why isn't this doing? Oh, okay. So we have done all these types of memory tests to see how they perform and how they scale, especially versus other collections frameworks and the JDK itself. These are a bit older, so this was run with Java 7 and GS Collections, so clearly they are not the most current versions, but we do keep these tests checked into our GitHub repository, so if you want to run them yourself and see how they run on your machine, feel free. So they're all available and you can check them out yourself. Here's an example of, I think this is just a plain object one showing the differences between using a mutable list, which is our GS Collections, Eclipse Collections version of a list versus the JDK array list versus a linked list. Where things get more interesting is memory savings with maps. So we were comparing the JDK hash map to Eclipse Collections, GS Collections, Eclipse Collections, same thing, Trove, and a JDK hash table. So a little bit more interesting here. Here's another one with mutable set, which is our version of a hash set. So you can see here you're really starting to save with memory savings behind the scenes. Bags, since there are no JDK equivalents, we have a comparison versus Google's. Concurrent map. And so there, oh, okay, and now here, this is the one that I believe I showed in my presentation, so showing you the savings of using a primitive collections list versus not. Again, primitive maps versus an object map. Primitive sets, and goes on. I can leave this up, or if you want, I can just leave the link up so everyone can take a look. But we do have a lot of interesting statistics here, so if you're curious, feel free to take a look. With that, that's pretty much all I had, so I'm happy to open it up to questions. Oh,
any questions?
Yeah, for Java 9, you had about the internal APIs on the slide. Which ones were you using?
I'm sorry, so in this example, just a second. So for Java 9, this was the problem when we called set accessible on data. This is what caused the issue for us. Any other questions?
Anybody else? All right. Did I miss anybody behind the poll?
Oh, we got one back there.
Thank you. Hi, thanks. How do you manage to reuse the what was it called? The lazy, was it interval stream?
Intervals, yeah.
Yeah. Do you like create one new one under the covers, or do you just reset it at the end?
So the way we have our API, we never made it an issue. You can reuse them as much as you want. For whatever, I don't know the design reason why streams are like that, but that's the design decision they made. But for us, we just never put in that restriction that you have to use them once.
Except for Java 9, can you tell us something that might be coming up on your roadmap?
I can show you. Let me pull up our GitHub. So, this is the kata if anyone's curious, but I'm going to go to the main page. So these are some pull requests, but we have our whole issue tracker with things that we want help with as well as things that we want to do. So you're free to take a look here, or if you want to contribute, feel free also. But this is pretty much where we document all the stuff that's upcoming and things that we might need help with if anyone wants to add to them.
All right. Thank you all for coming, and feel free to come up and chat some more.